In this video, we'll do a live demonstration of attenuation in an optical fiber. To demonstrate how fiber works, we're going to use this 30mm plastic rod. And to effectively get light in and out of it, we're going to polish the end. And we're polishing it just like we polish an optical connector. For our light source, we're going to use a laser pointer. Here you can see how it is scattered by the imperfect finish on the end of the plastic rod and how light is carried down the rod. There are two sources of attenuation in optical fiber, scattering and absorption. Absorption occurs at particular wavelengths, typically caused by residual water vapor in the fiber. Scattering, however, occurs when the light hits various molecules in the glass and bounces around. Scattering is highly dependent on the wavelength of the light. We can demonstrate how scattering works very easily with our plastic rod. We can easily see the scattering in the plastic rod just like it works in an optical fiber. When we shine our beam from the laser pointer down the plastic rod, you can actually see the ray of light as it's traveling down the rod. And what you're actually seeing is the scattering that occurs as the ray of light travels down the plastic. And this is exactly the mechanism that causes loss in an optical fiber. We can use our plastic rod to show the wavelength dependence of scattering. You've seen how our green laser pointer works. Let's add a second laser pointer in, a red one. And we'll couple both of them into the fiber and see the difference. There's the green. There's the red. You can hardly see the red, but the green is quite visible. And the reason is simply that the scattering coefficient of the green, shorter wavelength light is much higher than the red, longer wavelength light. And that's why the attenuation of an optical fiber is highly dependent on the wavelength of the light.